Hello class, weekly update 11. So you guys have been working hard. A couple assignments we'll go through. I want to share the screen and show some of your classmates' work. So you did constraint relaxation and then theory 2. I've graded both of those, put them in my spreadsheet, and then I'll finish with some announcements about, we're getting to the end of the class. We have final presentations, final exams. So I'll talk about that at the end here. Okay, so let's start with the constraint and relaxation. I'll share the screen. Okay, so all groups did a great job on this, and so I didn't even put it in the in OAKS. I just wanted to share a few comments here. So this is the group of Ashley Maddox, Kristen, Chloe, and Olivia S. So we now have just 3 final groups in the class. We've merged a couple times because a few people had some health issues this semester. And hopefully they're doing good and you're staying in touch with those people. I do worry about them. This group though, new super group, and I think all the groups did great job on these introductory problems, like noticing the pattern 3 and 5 with a number of variables and constraints. And then the problems growing 6 and 14, 10 and 30, and then 15 and 55. And everybody did a great job finding the pattern there. And I learned from, I think it was May's group submitted, like, I didn't realize Wolfram Alpha can like actually find the pattern and give you those closed form expressions. That's cool. That was neat to, what can it do these days? But that is pretty algorithmic, so you think about it. Nice pictures here from this group of the relaxed polytope is just the cube. And then we're getting adding constraint, we're lopping off part of that. So we start with the relaxed thing is bigger, and then we'll just keep shrinking it. So I think all groups got that one. Yes, true. And the only way it would stay the same, I think this group did a nice job thinking about that case. If it was redundant, it wasn't useful, right? So it didn't really lop off anything. Yeah, everybody seemed to get the point of this. This is just I think constraint relaxation, you seldom see it in a book. It's just a wonderful trick. Again, I learned it from this optimization wizard Yoshi over in Japan. He's now in his 70s. Okay, some groups picked one that took a lot less time, just randomly pick something. Nice to show above this what those, the -1 corresponds to the x56. And all of you worked around my typo there. That's an old MATLAB command. MATLAB probably told you that if you tried to type in, that stands for Binding Integer Program, which they've now changed to IntLinProg. It's a general case. Looks like everyone figured that out. And yeah, this was the group I think that had the luck of starting with the one they started. Only had 4 out of 40, but I think Jenna, Kevin, that group had to add 11 out of 40, but still way better than using all 40. And I think all the groups made this conclusion, but I really liked this group, Ashley Maddox, Kristen, Chloe, and Olivia S. Really talked about why they think just adding K at a time is better. Yeah, as the problem gets bigger and bigger and scales, absolutely. I mean, just get 1 or 2 or 10, because as you're, you could go through all of them, and that's just a linear system, which is much better than, or it's not even solving them, it's just checking, does this x solve bx equal b, or x equal b. So that's faster than actually, that's not O n cubed to do that, you're just doing a check. And yet, as the problem is huge, that's work. And so why go through all of them if you don't have to? A couple groups talked about doing it both ways. Maybe this is May and her group talked about they did it both ways, adding all of them, counted how many iterations it took, added like 10 or something, and saw how many it took. So that's a great way to check it and see what happens. And then the last one I wanted to talk about, does the X start from one iteration to another help? And it's not obvious that it does, but I just like this group's solution. But yeah, here's the first part, that if the relaxed problem is infeasible, then the original problem is infeasible. So that's a huge help right away. Saves you a lot of time. If you look at this, much easier problem, can't solve it, then you've modeled something wrong. Go back to the drawing board, start over. They also talked about how a bound is useful, and this is true. Like often when you add a bound, you add another constraint that the objective function must be at least this good. That can lock off a big part of your polytopes as well, and you can keep doing that as you're going along. And then the other reason I like their answer was just this phrase, tightening. Yes, we are tightening and tightening and tightening this problem until we get, we didn't have to look at the whole big thing. Maybe we're only looking at half of it, which saves us work, but as we go, we're tightening, and tightening is going to march you towards the optimal solution. So nice job for all groups. All groups got A on that one, but those are a few points that I liked from this particular group. Okay, and then let's check out theory 2. Okay, so then we'll go to your Oaks page. Okay, so I put this back in module 6 because that's where you had the theory 2, and then I dumped a few. So I liked Chloe, Ashley, Jenna, Kristen, and Naomi's, and for different reasons. So let's look at, like, I liked Chloe's because in hers she broke down for the first problem into cases. So, you know, she said if m is less than n, then hey, we definitely have a problem. We don't have enough independent vectors. If m equals n and we still have this problem with dependency, then we can't have an inverse. It's got to be singular. We can't get a basic feasible solution. And what this implies, so some people talked about, so this was a subtle one. Let's go back. Many people connected this to redundancy, but I want to be careful on how we said that. Like redundancy isn't necessarily bad. Like think about the one we just did, the constraint relaxation polytope that you are looking at. Highly redundant. If you have redundancy, it could potentially be that you're in the case of problem theory number 1. But as long as you have enough, I guess you need enough so that square matrix B, you need enough information that is a basis, right? So redundancy could cause you a problem there, but it might not. It might be you have many other ones that you didn't even need to consider. So redundancy in and of itself doesn't cause the problem of number 1, but it could. Okay, and then let's look at number 2. I liked, oh, actually, let's go. I think I also liked for number 1, Jenna. So let's look at that. Oh yeah, I like Jenna's summary here. This star. So in number 1, she's showing that the constraints serve as a quick way to check the feasibility, which was interesting. I hadn't thought about this. It's absolutely true. Like you could quickly check feasible or infeasible if you don't have any basic feasible solutions, right? Okay, and then for number 2, let's go back. I liked Naomi and Ashley. A lot of people, Avery, Mannix, Brianna, a lot of folks did a nice job on this one, breaking it down. And so I just put, let's take a look at Naomi's. Because in particular, Ashley and Naomi's were really clear for number 2, the structure. So many of you cranked away with the algebra, and that's kind of fun to get back to. She had why she was doing each one of these. But this part, right, there's an A. You have to prove that it's improving, and then you have to prove that it's feasible, which is really clear. Broken down for Naomi's and Ashley's as well. Take a look at those. And then number 3. Let's go to Jenna's for number 3. Yeah, so the reason I put Jenna's in here, many people got to the same conclusion, but I always like how Jenna talks about what she knows and breaks it down. Like initially, I'm thinking this. I don't think I can get an initial solution doing that idea, but let's see what happens. And ultimately, she gets to the same place many of you did. If everything's all ones and that additional variable n plus 1 is 1, then we know we can solve this. And many people did connect this to the big M and we have an auxiliary variable. So nice job on that. There's some key highlights I was looking for. And then lastly, let's look at Kristen's. So I went back and looked at my solutions that I made, and they look almost identical to Kristen's. And I think mine are less helpful because they're very compact and very short. So again, if you look at Kristen's proof, but this is almost exactly the way mine was. The implication the same, really short proof for improving and feasible, and she does show that right there. And then same thing, just a paragraph. She quickly got to the summary that we needed all once. There's an easy initial basic feasible solution. And so it was as tight and compact as mine. So I put hers instead. Okay, so nice job, mostly A's, a few, maybe one B and a couple B pluses on that. So really nice job as a class. Okay, and then some final announcements. So you have final presentations. And I don't think I put a due date, but these are due. So regardless of what it says, it sort of looks open, I think, in Oaks. But we're going to have your final presentations. You have 2 of them. So this is your last assignment. We're going to go back to, remember, day 1, we talked about the flight path planning problem and the national security problem, hurting over links and nodes in a network. So you're going to, for those problems, go back and see how much you now know, and you're going to act as if this was your work, these papers. You're going to reread them with your team and make a presentation. You have 2 presentations. You have a technical presentation that you have 15 minutes to do as a team. And this is for folks, all this is in Oaks, but it's for, assume your audience knows as much math. They've also taken this 451, 551 class. They know optimization. And then the second presentation is shorter, 7 minutes, but your audience now, in some ways it's more challenging. They are non-technical and you need to also work through this paper. So in this, these are supposed to be government briefings. So we're going to assume for the non-technical one, these will be like often they're your higher level folks, your colonels, generals, managers, don't know as much math, but they're very interested in this problem. Okay, and this is the other thing I want to point out. So this will be due Monday, December 6th at 11:59, like we usually have them. You're going to record this as a team, participate as a team. Each person has a role, and really spend a lot of time, because we now have almost, what, 2.5, 3 weeks, well, 3 weeks for this assignment. And this is a big part of your grade. And the other reason we want to knock it out of the park and do a great job, polished presentation in how you deliver, but also in your slides, put effort into that, making sure you understand the sections of the paper, and you're going to present the ones that have to do, watch the video that I've made about this, but present the sections of the paper that have to do with the linear or integer programming techniques that we've learned in this class. And then the other reason I wanted to do this is the graduate program director, Lee, Zhizheng Lee, collects these final presentations and your final exams to assess the graduate program. And she has to make reports that then go up to the higher level and then up to the state. So let's hit home runs on this. Big part of your grade, but also I think it's a fun assignment to see how far you've come with this and the uses of the work. And you're not having to write the papers yourselves, right? We're just going to demonstrate that we understand them. Okay, and then your final exam, a few folks have asked questions. That's going to be Friday, December 10th. So we're using our usual time class slot, which is 4 o'clock Monday, Wednesday. So if you go into the exam schedule, you can find our block, and ours is the Monday, Wednesday, 4 o'clock class meets for our final exam, Friday, December 10th at 4 o'clock. We'll do it as usual with our other exams have been proctored on Zoom. So we'll need to make sure we have our screens on. Okay, so we're really winding down, coming down the last stretch. Good luck with all your classes. I know it's a stressful time. Oh, and by the way, thanks for the comments and notes you put in when you submit your homework. I know it has been a rough week, but you're almost done with this class, and hopefully these assignments are fun and cumulative, like you're really feeling like you understand the material. And oh, and also Brianna, heart goes out to you on the having to have a pet. I know it's a rough time, pet that needs care or to be put down. So just let me know as you're submitting your other coursework, if anything comes up and I can help accommodate, let me know. And good luck. Again, it's a stressful time, but you can do it. Get through it.